Okay, so for page 4 and page 5, all of them is about the binary code. Okay, when we want to consider given a number of bits, then what are the number of possible binary code that can be represented? Okay, so in this table, you can see if we have one bit, that means you have only one space to put the number inside. And if we are using binary number to represent, that means in this one bit space, we can only put a 0 or only put a 1 here. Okay, we have only two choices. Okay, so given to you one bit, the number of possible binary codes should only be 2. On the other hand, if the number of bits is increased, if it is increased to 2, then the possible binary code that we can only put 0 and 1 inside, they will be 0, 0, 0, 1, 1, 0, and 1, 1. Alright? And someone may say, can I put another one? Let's say 1, 0 here. The answer should be no, because there will have two possible codes with the same number. Okay, so they are repeated. Alright, so we should have only one of them there. Okay, so in this case, we have 1, 2, 3, 4. 4 possible binary code only. Alright, so number of bit 2 will have 4 different possible binary code there. Let's go on. If we have 3 bits, then we can have 8 binary code all over. And which are those 8 binary code? If you try to write them out, you may feel that it is quite difficult because the combination, the possible binary code will be so many. So I will introduce another method for you, such that you can know how to fill in all these code inside. You can use a tree diagram to represent it. Okay, so how to use a tree diagram to help you? Let's see. First of all, if we have only one bit, all the possible outcomes should be 0 and 1 only, right? If there is 2 bits, that means the first bit can be 0 or 1, and the other bit can also be 0 or 1. So if the first bit is 0, the second bit, or I use different color, will be 0 or 1. If the first bit is 1, the second bit can also be 0 or 1. So altogether, the all possible outcome will become 0, 0, 0, 1, 1, 0, and 1, 1. Okay, so you can see that if we have 2 bits, there will have 4 possible outcomes. Alright? If you are given 3 bits, that means whatever the number before, it can still be 0, 1, 0, 1, 0, 1, and 0, 1. So all together, Okay, I cross out this result. So all together, we can have 0, 0, 0 as the first one, 0, 0, 1 at the second, 0, 1, 0 as the third, and let's go on, 0, 1, 1 as the fourth. And on the other side, we can have 1, 0, 0, 1, 0, 1, 1, 1, 0, and at last 1, 1, 1. Okay, so you can see here we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so altogether we can have 8 different possible combinations for 3 bits. Okay, and for this exercise you should try to find the possible outcome of 4 bits. Okay, try it yourself. That is. So back to here, you can try to use the method of tree diagram on the next page to find all the answer here. Okay, and the result should be 16. Alright, so let's take the summarize it. If the number of bit is 1, then the number of binary code will be 2. If the number of bit is 2, the number of possible binary code will be 4, and we can see that 4 is equal to 2 times 2. And then if we have 3 bits, the number of binary code will be 8. 8 is 2 times 2 times 2. And at last, if we have 4 bits, then we'll have 2 times 2 times 2 times 2 results. Okay, so if we use index to represent them, we use index notation, we can see that actually 2 times 2 times 2 times 2 is 2 to the power 4. 2 times 2 times 2 is 2 to the power 3. 2 times 2 is 2 to the power 2. And 2 is 2 to the power of 1. Okay, and you can see this result actually is the number of bits of the number. Okay, so we can have a summary that if we want to know the number of possible binary code, if the number of bits is given, the formula should be 2 to the power number of bits. Okay? Alright? Okay, now let's complete the table together. So the table say, for the first example, if number of bit is 1, the number of possible binary code should be 2 to the power 1. That is 2. If the number of bits is 2, the formula will be 2 to the power 2. So the number of possible binary code should be 4. Let's go on. If the number of bits is 3, so the formula should be 2 to the power 3. So it is 2 times 2 times 2. That is 8. And then 2 to the power 8. This is 2, 5, 6. And then 2 to the power 10. 2 to the power 16. 2 to the power 24. For this case, you should try to use the calculator to find them out. Okay, so I will give you the answer here, but I want you to try them by the calculator. Alright, so for 2 to the power 10, it should be 1024. 2 to the power 16, 65536, and 2 to the power 24. Alright, so these magic hours are quite important. If you can remember, then I think you should try to remember them. If not, at least these highlighted number should be remembered. Alright, because they have many meaning in computer science. Alright? Okay, that's the end of this video. See you.